Hello class, welcome to today's lesson, and we're going to talk now about application problems involving ratio. We are still solving application problems, but now I'm going to introduce this new concept of ratio. Okay, the translation of this into Spanish is razón, la razón entre dos números, o la razón de dos números, o la razón de un número a otro. Okay. Ratio. So let's see, what does that mean? Let's read the definition first. The definition of ratio is the following. We say that the ratio of A to B in that precise order, okay, the ratio of A to B, commonly represented by this symbol, okay, it's gonna be the A and then like a colon or 2 points and then B, is the quotient A over B. In other words, the ratio of A to B, this is how you read this symbol, guys. The ratio of A to B is simply the same as the quotient of A over B. That's all it means. That's all it means. It's a simple division. It's that simple. Okay, let me give you other ideas in here. Let me further explain what this means. For example, consider the two numbers 12. Let's consider the number 12 and the number 8. Okay, 12 and 8. We have two numbers, and we usually say that, for example, these numbers are in a ratio of, that would be 64. Let me calculate. Yeah, 3 to 2. Okay, look, we say that these two numbers, 12 and 8, are in a ratio of 3 to 2. Why do we say this? Because the ratio of 12 to 8 is this, right? This is the ratio of 12 to 8 according to my definition. Okay, the ratio of 12 to, let me actually write the whole. The ratio of 12 to 8 is simply the division of 12 over 8. And if we perform this division, we can see that it's the same as 3 over 2, right? Or it's the same fraction. 3 times 4 is 12, and 2 times 4 is 8. So these two numbers, 12 and 8, are in the same ratio as the ratio of 3 to 2. Okay, these two ratios are the same. Okay, and this is a good way to introduce what we know as the ratio in lowest terms. What does this mean? Okay, if I suppose, again, I give you these two numbers and I ask you, please give me the ratio of these two numbers. Give me the ratio of 12 to 8. Then your answer could be simply this, writing this. This is the ratio of 12 to 8, and that would be perfectly okay. All right, there's nothing wrong with that. You don't have to perform the division, okay? You don't have to perform 12 over 8. We usually keep the ratios in this sort of notation. We don't carry out the division, okay? Because 12 over 8, that's going to be equal to 1.5, right? But no, we never do that in ratios. Well, we don't usually do that. We keep it in these symbols. Now, if I ask you, give me the ratio of 12 to 8 in lowest terms, then what you have to do is not performing the division, but simplifying. Okay, like so. This is the ratio of 12 to 8. and it can be simplified as the ratio of 3 over 2. So the second answer for the second question would be this. This is the ratio of 12 to 8 in lowest terms. In lowest terms. This is also the ratio of 12 to 8, but this is not in lowest terms. And we usually, 99% of the time, when we talk about ratios, we always we try to always put them in lowest terms, always, okay? So for example, if you want to get the ratio of, let's say 5, what is the ratio of 5 and 10? Okay, what is the ratio of 5 to 10? Then the ratio of 5 to 10 is simply this, right? Okay, which can be simplified as 3 over, no, I'm sorry, 1 over 2. 1 over 2. Okay, when you simplify this division, you get 1/2. And so the ratio is the same as the ratio of 1 to 2. We say that the ratio of 5 to 10 is the same as the ratio of 1 to 2. And what does that mean graphically or visually? Well, it means that, let's say that if you have a column of 5 units, okay, you have 5 units, and then you have a column of 10 units, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, this is 5 units, this is 10 units, and if I make other two columns of 1 unit only in 2 units, what that means is that these two representations bear the same resemblance, the same proportion to one another. Okay, basically what we're saying by saying that the ratio of 5 to 10 is the same as the ratio of 1 to 2 is that this second number, the largest number, is twice the previous one, twice the smallest one. Okay, in both cases, the numbers are different. In all of these cases, we have 5, 10, 1, and 2, but the ratio is the same. The ratio is that this number is twice this number, or you can look at it in the reverse perspective, right? This number is half of this number, and the same in here. This number is half of this number. That's what we mean by saying that the ratio of 5 to 10 is the same as the ratio of 1 to 2. That's more or less the conceptual understanding of this word, ratio. Okay, now another idea, another concept is that of proportion. What do you say proportion? It's not the same as a ratio, but it's got something to do with it. We say the following. We say that four quantities or four numbers, A, B, C, and D, are proportional. Okay, we say all of this phrase. We say that four numbers A, B, C, and D are proportional if the ratio of A to B, which can be written like this, is the same as the ratio of C to D. Okay? Another way to put this, the ratio of A to B is the same as the ratio of C to D. These two rectangles say the same thing in different with different symbols. Okay, so that's what we mean by a proportion, guys. A proportion is constructed with four numbers, A, B, C, and D. And basically a proportion, you can see it as an equality or an equation between two ratios. That's what it is. Okay, now let's go and solve some application problems regarding the ratios. For example, I'm going to solve three examples. Okay, and the first one is this. we read the following. The ratio of two integers is the same as the ratio of 9 to 7. Okay, so let me start by declaring my integers. I'm gonna call A and B first integer and second integer. Okay, and so they tell me that the ratio of these two numbers is the same as the ratio of 9 to 7. So I can write this, the ratio of A to B is the same as the ratio of 9 to 7. Another way I can write this is in the following way. The ratio of A to B is the same as the ratio of 9 to 7. These two rectangles mean the same thing. Okay, let's go. So basically, if you can see here, guys, we already have an equation. Let's call it equation 1. Next, we have the following. The sum of the integers is 390. So we have another equation. We have A plus B is equal to 390. I have another equation that relates my numbers A and B, and let me call it equation 2. And the task is finding those two integers. Okay, so let's do it. I have two equations to work with, this one and this one, and you can do the following. Look, I'm going to convert this equation into an equation without denominators. I've already shown you how this is done. I don't want denominators in here. So how can I get rid of b as a denominator? I multiply both sides by b. And you're going to get a equals 9b over 7. And then I multiply both sides of this equation by 7 in order to get rid of this denominator. And the result will be 7a equals 9b. Okay, so this is the same equation as 1, but in a simpler version, so to speak. Okay, now look at what I'm gonna do. I'm gonna isolate one variable from this equation. I'm gonna isolate a. So we have that a equals 9b over 7. You see? And what am I gonna do with this? What I'm gonna do is I'm gonna use it and combine it with my other equation, with this one, with equation number 2. Instead of a right there, I'm going to place 9b over 7 because according to this equation, 9b over 7 is equal to a. So let's do it. I'm going to take equation 2 and, well, let me write that. Taking equation 2, we have that 9b over 7. Okay, I'm substituting this plus b equals 390. And if you realize, we have obtained an equation which only has one variable, which is b, and we can solve it. So let's do it. We have 9b over 7 plus 7b over b equals 390. Why did I do this? No, I'm sorry. 7b over 7. Did you see what I did? I converted this b into 7b over 7. That's one trick you can do. Why did I do that? Because now I can add these two fractions because they have the same denominator. So I'm going to get 9b plus 3b over 7 equals 390. And then I'm going to multiply both sides, this side and this side, by 7. And I'm going to get the following. 2,730, and then we have 10b equals this much, and therefore b equals 273. So we have found b. We have found my second integer, And then how do I find the first integer? Well, I can use either of my original equations, either the first one or the second one, with this value that I just found. I already have b. Okay, so all you need to do next is plug it or put it anywhere in these two equations so you can find a. So uh, putting b back on equation 2, I'm gonna get a plus 273 equals 390, and that's gonna give me that a will be 117. And the problem is solved because I have found my two integers. Okay, and that's how you solve this problem in particular. Well, that's one way you can solve it. Okay, next problem. Let's see. Problem number 2. We have the following. In a school there are 1,155 students. From a random sample of the students, you can determine that the ratio of girls to boys is the same as the ratio of 4 to 3. How many girls and how many boys are there in the whole school approximately? Okay, let's start. So we can declare my variables, okay? For example, I can say that G represents the number of girls in the school, and B will be the number of boys in the school. Okay, so this is what G means and this is what B means. And basically, how can I translate this first statement, this little one here? In a school there are this many students. Well, I can write this equation. The number of girls plus the number of boys in the whole school will be equal to 1,155. Okay, this is my equation 1, and I keep it here because maybe I'm gonna need to use it. And then they tell you that when you take a random sample, what is a random sample? It's kind of like you go to the school and you pick, I don't know, like among these many students, you pick, I don't know, let's say 30, okay? And among that's what a sample means. It's kind of like a muestra, es una muestra aleatoria. Okay, so observing this sample, you notice the fact that the ratio of girls to boys in this sample is is the same as the ratio of 4 to 3. What does that mean? What that means is that you have 4 girls for each 3 boys, okay, in this sample. For every 4 girls, you have 3 boys. Basically, that's what it means. And so basically, you can come up with another equation. You can come up with the equation that the number of girls, the ratio of the number of girls to the number of boys in the school is the same as the ratio of 4 to 3. Now, well, let me call this equation 2. There you go. Now, this is not this assumption is not precisely correct. Okay, I cannot be certain that the number of girls in the whole school to the number of boys in the whole school will have that same ratio because I just took a random sample. So when you take a random sample, the facts that you observe about the sample are just approximate. Okay, that doesn't mean that in the whole school this ratio will be kept in the same way, but it's mostly that it's going to be mostly 4 to 3. That's why we can make this assumption. Okay, so how can we write this proportion in another way? We can say this: the ratio of girls to boys in the school is the same as the ratio of 4 to 3. And this is again my equation 2 in a more manageable or familiar way without these 2 points. I know that this is a little weird, but this is we know how to handle this. Okay, so now one more time, guys, we have two equations. Look, we have this equation that relates my variables g and b, and we have this other equation that also relates my variables g and b. And by using them and combining them, we can solve the problem. Uh, I'm gonna I'm gonna let you do this one on your own, okay? Because it's pretty much the same. Now that we know this, okay, these two equations, the rest of the solution is identical to the previous problem. Identical. I want you to understand that the structure of this problem from now on, now that we have written these two equations, the solution, all of this stuff is identical to the previous problem. Okay, so you just have to follow that same idea. And I'm gonna wait for your answer in a moment. Okay, and then the final problem for today. This one, problem number 3. Uh, well, there it is. Okay, problem number 3 says the following. The sides of a triangle have a ratio of 7 to 10 to 11, and its perimeter is 112. What is the length of each side? Okay, so let's see. First, let's draw the little triangle, the triangle, more or less. Okay, we have 3 sides, and what they tell you is this, guys. The ratios of these sides are the same as the ratio of 7 to 10 to 11. And I have not told you yet what something like this means. Okay, this is like a triple ratio. What this means is the following. Let's label the sides. I'm gonna call this side A, this side B, and this side C. Okay, what this means, guys, when you observe something like this, it's kind of like not a triple ratio. This is a double ratio. What this means is the following. That the ratio of A to B is the same as the ratio of 7 to 10. Okay, that's the first part. Okay, that this double ratio is telling you. The ratio of two sides, A to B, is the same as the ratio of 7 to 10. So we have this already. And the other part, this other part in here, this other part, what that part tells you is that the ratio of the two largest sides is the same as the ratio of 10 to 11. So what are the two largest sides? B and C. So now we know that the ratio of B to C is the same as the ratio of 10 to 11. You see, like so. And we have another equation. And remember, this is you can if you feel more comfortable writing the other version of this equation, do it. Like the ratio of A to B is equal to the ratio of 7 to 10, and the ratio of B to C is the same as the ratio of 10 to 11. I know we are mostly used to this type of equations, so we use them. These two things are equivalent, and these two things are completely equivalent. Okay, perfect. So that's what this means, guys. When you see something like this, like a double ratio, that's what it means. Okay, and then the other statement, we know that its perimeter is 112. The perimeter of this triangle is 112. And the perimeter, as we know, is the sum of all its sides. A plus B plus C is gonna be 112. So A plus B plus C will be 112. So this is my last equation. This is my equation 1, this is my equation 2, and this is my equation 3. And now that I have completed writing my equations from reading my problem, now I try to play with them and see whether by doing something, some process, some logic, I can get the problem solved. Okay, here we go. First, same idea. Equation 1 and equation 2, write them without denominators. I'm going to do it not automatically, immediately. And if you want, stop the video and make sure that equation 1 will look like so. This is equation 1. Equation 2 will look like this. Okay, and equation 3, we're going to keep it in the same way. Okay, make sure of this, guys. Okay, now what do? We do the following. Look, if you notice, these two equations, equation 1 and equation 2, have one common variable, which is b. You see? And this other equation also has b. So I'm gonna tell you what to do in this case. What we can do is the following. I'm gonna isolate from equation 1, I'm gonna isolate a, and from equation 2, I'm gonna isolate c. Okay, I'm gonna do that first. I'm gonna isolate my variable a from this equation, and I'm gonna get that a is equal to 7b over 10. So I have isolated a in terms of b from equation number 1. I'm gonna do the same in equation number 2. I'm gonna isolate the variable c in terms of b. So I'm gonna get that c equals 11b over 10. You see, I have isolated c in terms of b. And why did I do this? Because now I can take my equation number 3 and put these two values. This is a is equal to this. Can you see? C is equal to this. And I can replace these two things, a and c, in here and in here. I'm going to do that next. Now I'm going to take equation 3 and I'm going to do this. Equation 3 starts a. What is a? A is equal to 7b over 10. So I'm going to write that down. 7b over 10. There you go. Plus b. So I write plus b plus c. But what is c? C is equal to this. 11b over 10 equals 112. And if you notice, we have obtained, like we always do, an equation with just one single variable. And since it has just one variable, we can solve it. You see, my variable is b. And now I can solve this equation. When you have an equation like this, guys, that has two variables, you cannot solve it because you have two unknowns. The only way in which you can actually solve an equation is when it has only one unknown. Okay, so now let's solve this equation. I'm going to do the same trick that I did a moment ago. I'm going to write 7b over 10 plus b, but I'm going to write this b with the same denominator as these two other fractions. I'm going to do this. Look, 10b over 10. You see? Because this is the same as b. When you cancel this 10 with this 10, you get b, right? So it's the same. This and this are the same. And the reason I wrote it in this way is so I can add with the other two fractions which have denominator 10. You see? Nice. Okay, now let's do this. 7b plus 10b plus 11b over 10. I'm adding those three fractions equals 112, and then I multiply by 10 both sides, and I get this much. And then I'm gonna add these three terms, and I will get a 28b, right, equals 1120, and then we divide over 28 both sides so that we can finally get b equals, let's perform that division in the calculator, B will be equal to 40. Okay, so we have found one of the sides of my triangle. B is equal to 40. And the next is a piece of cake. Why? Because now that you have this value for B, just put it either here. Well, you can put it here, you see, in this equation 1, so that you can get A. Can you see that? And also you can put it here in the second equation, 11 times 40, so that you can get the value of C. And that's it, guys. Problem solved. Do that on your own. Get me the values for A and C, and you're gonna tell me those values in a moment. But basically, we know that the problem is completely solved. Okay, guys. So that's the idea behind ratio. Okay, get used to seeing this the ratios written in this way. Okay, and if you don't like it in this way, remember that it's the same as this. The ratio of A to B is the same as the quotient of A divided over B. It's the same thing. Okay, guys. So that's about it. Now it's question time. If you have questions, tell me, and let's work on the exercises. Thank you so much.